had 27 to the power of 2 over 3. Now, if you remember, if you want to crunch numbers, reduce numbers, or simplify things, you want to reduce the numbers first instead of making them bigger, right? Remember when we were doing multiplying fractions, you didn't multiply all the numbers up top, multiply the numbers on the bottom, and then break them into prime numbers and kill them, right? What you did was kill whatever you could kill and then multiply things up. So the same type of principle works here. When you're evaluating numbers, simplifying numbers, what you want to do is reduce them first and then make them bigger if you have to. So to reduce numbers, you're going to deal with the fraction, the exponent first, because that's a radical, that's a root. So it's going to make this number smaller, and then you're going to square it. So the way it works is, whenever you get fractions in the radical, usually deal with the denominator first. And 3 here means it's the cube root of 27, right? So this will be cube root of 27 squared. Now, cube root of 27, break down in the street your prime factors. 27 is 3 times 9, and 9 is 3 times 3, right? So 27 is 3 times 3 times 3, and you want the cube root of it. That means you're looking for triplets. Well, you got your triplet right here. So these guys come out of the root symbol as a single 3. So this will be 3 squared, right? And 3 squared is 9. Okay? So 27 to the power of 2 over 3 is just 9. So that's the way rational numbers work. So basically with the natural numbers, if you put anything from the natural number set in the exponent, it clones itself. The number of times it says you should clone it. If you put anything from the whole number set, it clones it if it's one of the natural numbers, which is 1, 2, 3, all the way to infinity. And if you include the 0, if you put a 0 up top, it makes whatever is here, the whole thing, equal to 1. If you go to the integers, with the integers it flips it. With the rational numbers, it puts it in the radical, and it basically becomes the root of. Now I'm going to do a lot of examples with this stuff, and hopefully you can see it. I'm going to start off slow and break it all down. With the irrational numbers, you just put the irrational number there. If it's negative, then it flips it if it's an irrational number. Irrational numbers are, you know, they're a special case. So we're going to deal with those later. They basically include everything here. You just can't do it as nicely. Break it down and stuff. Well, you can't. You need a calculator to do it, or you got to be really good at doing it by hand. Okay. So this is basically our real number set applying to anything in the exponent, and exponents are basically radicals. Okay, so exponents are radicals. They come from the rational number set. Okay, we're going to do a lot of problems with these things because I know it sort of becomes complicated, and you've got to be really good at simple algebra, which is just basically addition, multiplication with fractions, and just break it all down, because it's again, like I said before, you have to be able to massage numbers, break them down, and really understand the real number set, because this whole thing, this real number set, is the majority of the numbers, should be almost all the numbers you deal with in high school, except if they introduce imaginary numbers, the square root of a -1, of negative numbers, basically. So the real number set it's crucial for you to understand this, because it applies everywhere. One of the first places it applies, it breaks it down into its different sections in the exponents, which is, again, a huge part of high school mathematics, where you have to learn how to break numbers down. And all of this whole thing is really not dependent on, but it's really important for you to know the prime numbers, because you use prime numbers, you break things down basically based on their prime factors, especially in the rational numbers in the exponent, which becomes radicals, the root of, the cube root of, square root of, the fifth root of, whatever root of. Whatever number is in the denominator, we're over here. Whatever's the number in the denominator goes to the radical. So whatever you put there, that's the root you want. So all of that is dependent on you being able to break things down into their prime trees, prime factors. Okay, super important. We're going to do a lot of examples with this. Hopefully this made sense. I had to do this real quick. I've come here like 4 times, and it's always been busy, so we had to get it done. We had a little lull period there, okay? So go through this, and we're going to have a lot of examples coming up with the new exponents.
Okay.
Yeah. So basically, it's broken down into natural numbers, whole numbers, integers, and rational, and each one does a special thing.
It says that down here goes 1, 2, 3 clones itself, it repeats itself.
Yeah.
Like you said?
Yeah. So it does. You want me to show you?
Yeah.
Yeah. If you put, let's say, the number
Yeah. Oh, this part. All right. That's right. All right. See you later, buddy. Yeah. Oh, this part. All right. That's right.